Alright guys, welcome to the channel, and if you haven't subscribed yet, please subscribe for more content. So this time we're going to talk about series circuits. So series circuits will basically look like this. So we have a DC source. This could be a battery or any other source, and then let's put some wire, and then of course we're going to have a series of resistor. So that's the reason why we call it series circuits. So let's consider that we have a 4 resistor in series right here. So they have the same branch of connection. Oops. Yeah. So this would be our total voltage, the source, and then the current will flow through right here. That would be the arrow. This would be the current total. So the conventional current flow for analysis will flows from the positive, from here positive to the negative. However, when we try to think of the actual movement or direction of the electron flows, yeah, it came from the negative to the positive, so it's quite opposite. However, we use from positive to negative for analysis purposes. Okay, so let's call this R1, let's call this R2, and let's call this R3, and let's call this Rn. So n represents any real number. It could be 4 and then 5 or else. Okay, so series circuits. So how do we able to calculate the total resistance? The total resistance. So the total resistance in terms of series circuits will we just have to add all of them. So let's put this RT equals to, let's add all of them, 1, that is R1 plus R2 plus R3, and then plus Rn, that's plus, and then so on and so forth, Rn. So this would be the formula for in terms of calculating the total resistance. So when we already calculate the total resistance, this circuit would look like we have a source right here, the same value of the voltage, and then we are going to only have right here one resistor, and this would be the RT, and we have the IT. So this circuit and this circuit right here is equal. Okay, so that's just for highlight. Let's erase this one moment. Okay, so we already have the total resistance. How about the current? So in series circuits we have a constant current. So current would be equals to VT. Okay, let's call that red. In terms of Ohm's law, VT all over, of course, RT. So that would be the value of our total current. So it is also equals to I1 equals to I2 equals to I3, and then equals to so on and so forth. So whatever current that flows through R1 to R2, through R3 and through Rn, that is the same as the total current that we have here. So how about the voltage? How do we calculate the voltage? So voltage would equal to we just have to calculate that through Ohm's law when we have the total current, and then that is multiplied by the total resistance. So since we are in the series circuits, basically there would be voltage drop across the resistors because of the resistor itself. So even if there is the same current that is flowing through in the series circuit, we have voltages drop right here. We have voltage drop across R1, we have voltage drop across R2 right here. Let's call this V1. We have also voltage drop right here. Let's call this V2. Okay, let's color that into green. There would also be voltage drop right here across V3, I mean R3, and this there would be voltage drop across right here. Let's call this Vn until the voltage from the total voltage from the source, because of the voltage drop across the resistors, that would leads to 0 volt right here, and then that would eventually go back to the source. So therefore, if we try to find the value of V1, so let's put V1 right here. So in terms of Ohm's law, that's just I1 or IT, because I1 and IT are equal, and then multiplied by R1, and then also V2 is equals to IT or I2, they are the same, and then multiplied by R2, and then V3 is equals to IT or I3, they are the same also, and multiplied by the resistance right here, the resistance 3, and then Vn is equals to IT multiplied by the resistance Rn. So n represents any real number. We could also use notice that we form a voltage divider right here, so we could use the voltage divider formula. That's the reason why we only use, or voltage divider theorem is only applicable for the series circuits. So let's find the value or the formula of V1 using voltage divider. So that would be V1 is equal to the voltage or the total voltage multiplied by the resistance right here, the R1, since we are trying to find V1, so we have R1. So the numerator would be resistance 1, and then divided by the total resistance. So if we choose this formula, we would have the same outcome when we also use this formula. They are both the same, and then that is also the same to V2. We just have to we have a total voltage multiplied by, since we are talking about V2 right now, we are going to have R2 right here, and then divided by the total resistance. The same also to V3, that is the voltage total multiplied by the R3 divided by the total resistance, and also the Vn, that is the total voltage multiplied by the Rn all over the total resistance. So if we try to use this one and try to use the one, we will have the same outcome. So that would be for the total resistance, the current, and the voltage. Also for the power, let's have the power. Power would be just equal to Vt, or the total power will be equals to the total voltage multiplied by the total current, or we could also use the Pt is equals to the It squared, and then multiplied by the total resistance. So it is also equal to the P1 plus P2 plus P3, and then plus so on and so forth Pn. So where, let's put right here because this has space, where P1 is the power that is being dissipated in across R1, so that would be, let's use this formula for R1 for P1. So that would be, so since we have the same current as the total current, we can use the It squared, but we have to multiply it by R1 since we are talking about the power being dissipated in the resistance 1. That is also the same to the P2, which is It squared multiplied by R2. P3 is equals to It squared also multiplied by the resistance 3, and then the Pn is equals to It squared multiplied by the resistance Rn. So right now we already have all the formula for all the parameters or important parameters for the series circuits. So in the next video we will have a two examples of the series circuits. So make sure you have to see to watch that video, because you will understand further for more. So that's it for this video, guys. Thank you for watching, and God bless.